This video will review how to do algebraic operations on rational expressions. We'll first start with multiplying and dividing and move to adding and subtracting a little bit later in the video. So to multiply two rational expressions, as we can see here in the notes, essentially we're going to multiply the numerator parts, in this case they're labeled P and R, together, and then we'll multiply the denominator parts. Here they're labeled Q and S together, and then after that multiplication we can simplify whatever results to write our fraction in lowest terms. So for our first example, we want to multiply 1/4 and 8/9. So we can see that the fractions aren't quite written the way that are considered a best practice. You always want to write your fractions in the format where you can really clearly see what's the top of the fraction and the bottom of the fraction. So the way that they're written right now with 1-4 to represent 1/4, it's not really as obvious that 1 is in the numerator and 4 is in the denominator. So it's always a good practice to write it in the format that I did here, where you can clearly see what is the top of the fraction and the bottom of the fraction. So following our multiplication rules, I'm going to multiply across the numerator. 1 times 8 is 8, and across the denominator 4 times 9, which is 36. And then once we have done the multiplication, we would want to simplify the result. So here, hopefully we would notice that there's a common factor of 4 for 8 and 36. So we can think of dividing essentially that 4 out, leaving 2, and then we have a value of 9. So the final simplified fraction would be 2/9. So this is one way to perform our operation. This can be hard though, because when we do the multiplication we might get some very large numerator and denominators, and it may not be as obvious how we simplify that fraction. So there is an alternate way to do this that I'm going to show you now that involves simplifying before you've actually performed the multiplication. So I might have noticed that I do have this factor of 4 here in the initial problem. I have a 4 in the denominator and an 8 in the numerator. So I could go ahead and simplify out or divide out that factor of 4, leaving a 1 in the denominator and a factor of 2 in the numerator. So here we're doing that simplification on the front end. So then I'd be left with 1 times 2, which is 2 in my numerator, and 1 times 9, which is 9 in the denominator. So we can see we still get the same final answer of 2/9, but it involved smaller numbers because we simplified on the front end instead of after performing the multiplication. So how do we multiply rational expressions when we have more than just numbers? Well, we're going to again try and do that simplification first to just make our problem a lot easier. So we're going to first completely factor the numerators and denominators of our expression, and we're going to go ahead and simplify out any common factors, and then we'll multiply whatever remains for our numerators and denominators. And then we always want to review that final answer and see, is there anything that we could potentially simplify further to write our fraction in lowest terms. So looking at our first example here, I want to go ahead and break down each of my values into their factored forms. So 6 I could rewrite as 2 times 3, x squared as x times x. My denominator 10 could be written as 2 times 5, x cubed is x times x times x. Then for my second number, 5 and x, I can't really break down further. 12 though I could, it's 2 times 6, and then that 6 could be broken down further as 2 times 3. So when we have it written down in this completely simplified form, then those common factors that are going to divide out or simplify out become a lot more obvious. So I can pair it up. The first set of 2's will simplify. I also have a set of 3's that can simplify out, a set of 5's, and then here again I need a paired set. One factor in the numerator and one factor in the denominator can cancel. So I have 2 sets of x's and then a third set of x's. So actually here, when it's all said and done, I end up getting almost what looks like nothing left in the numerator, but there always has to be something remaining. So by default it's going to be a 1 if you don't see any obvious factors. Here everything's simplified out, so it's like a 1 for my first denominator, multiplying by 2 times 2, which is 4. So this whole expression ends up becoming 1/4 after we've simplified everything. Now for some more complicated algebraic expressions, the rules still remain the same. We want to go ahead and factor these completely. So I'm going to just look at each part of the fraction to start. So looking at my first fraction's numerator, I can see 4x and 8 do have a common factor of 4 that I could pull out as a greatest common factor. leaving x plus 2. The denominator, again, we can see they have some things in common. They have a 7 and an x in common as a greatest common factor. When I pull that out, I'm left with x for the first term and minus 2 for the second term. So that's my first fraction written in the factored form. My second fraction, I have a trinomial, which we can factor into two binomials. So I'm going to break down the 3x squared as 3x times x. Then I need factors of -2 to be placed just so that my outer and inner terms will yield this -5x. So I'm going to give -2 and +1 a try here, and then I'll go ahead and check it very quickly. So 3 times -2 gets me -6x. 1 times x for the inner terms gets me 1x. When I combine those, I do in fact get the -5x that I was hoping for. Then for our denominator, I can see I have two perfect squareds numbers. This is 3x squared for my first term, and 1 squared gets me 1. So it's a difference of perfect squareds there. So I'm going to have 3x minus 1 and 3x plus 1 as my factorization for that difference of perfect squareds. So I've done my factorization, and now we can go ahead and look for any common factors to go ahead and simplify out. So I can see that I have a common 3x plus 1 factor on the numerator and denominator that we can get rid of. I have an x minus 2 that's a common factor. And then I'm going to keep looking, and I don't see any other common factors. There's no other matched factors that would go ahead and simplify out. So what I'm going to be left with here is 4 times the x plus 2, and then 7x times the 3x minus 1 in our denominator. Now here, depending upon what course you're in, some courses want you to leave your answers in this factored form. For instance, if you were taking a calculus class, you'd likely leave your answer in this form. Some classes, they want you to go ahead and remultiply. So if I did want to go ahead and redistribute my values here, I'd have 4 times x, and then 4 times 2, which is 8 for my numerator. For the denominator, we would also distribute. 7 times 3 gets me 21. X times x yields x squared, and then minus 7x for my other term. And we know that this is simplified because if we could have canceled out any factors, we would have. So even though it doesn't necessarily look simplified, it is our simplified form. We've just multiplied everything out so that there's not any additional operations to perform. All right, for division of rational expressions, we're going to leave our first fraction alone, but we're going to multiply by the reciprocal of the second thing, or the fraction that we're dividing by. So there's lots of different mnemonic tricks. I've heard keep, change, flip, right, to represent keeping the first fraction alone and multiplying by the flip or reciprocal of the second fraction. And there's other different variations of that same sort of rule. So essentially, to perform the division, we have to change it into multiplication, and the fraction that we're dividing by needs to be reciprocated or flipped before we can perform the multiplication. So using that rule, the first thing I'm going to do is go ahead and keep my first fraction the same and multiply by the reciprocal of my second fraction. So that's a good rule of thumb. Don't worry about simplifying or doing anything. Just go ahead and convert that the division into multiplication. Then using the same rules that we did for multiplication, I want to go ahead and simplify all of my factors here and write them all out in the factored form. So 3x cubed and y to the 7th, 3, 4, 5, 6, 7. And then 40 can be broken down as 2 times 20, which is 2 times 10, which is 2 times 5. Now, if this looks like a more complicated way of doing the division, there are faster ways. If you know about the power rules and how division of powers work, then you can definitely go that route and avoid kind of writing out all the factors. I like writing out the factors because if you're a new learner or struggling learner, this is just a very helpful way to make sure you're always getting to the correct answer. So 4 I can go ahead and break down as 2 times 2, and then x cubed. And then again, looking for those paired values, I need one factor on top and one factor on the bottom to cancel. So I'm looking at 3. I don't have any 3's on the bottom. X's, I do have 3 x's that we can cancel out. And then y's, I don't see anything to cancel. For 2's, they're all in the bottom. I don't have 1, 2, or any values of 2 in the numerator that can cancel out. So when it's all said and done, I have 3 left over. I have 7, 8, 9 y's. That'll become y to the 9th. I have 2 times 2 times 2 times 2 times 2. So I have 5 values of 2 and then a 5 as well that we need to multiply all together. So these will essentially become, the first fraction is 40 times 4, that's 160 that's left for my denominator. All right, now this division is a little bit more complicated because now we have trinomials and binomials, but the procedure is the same. I'm going to keep my first fraction in the exact same format. I'm going to change division into multiplication and flip or reciprocate my second fraction. Then again, we want to factor everything so we can see if there's any common factors that we can go ahead and cancel out from our multiplication of our fractions. So factoring my first trinomial, I get 3x times x. Factors of 8, I'm going to go ahead and try 4 and 2. And because I want them to multiply to be positive but add to be negative, I know that these both need to be negative. And I'm not sure this is going to work here. I might have to move the way I've placed my factors. So the outer set will get me negative 12, inner set negative 2. That's a negative 14. So that did not work. Let me see if I change these two numbers and their location. Oops, that didn't change it. If that makes it better and gets us that negative 10. All right, so now I think this will work. Let's give it a shot. So 3 times negative 2 gets me negative 6x. Negative 4 times x is negative 4. If I combine those, that is indeed the negative 10 that we were hoping for. So now that I know that I have successfully factored that, we can continue working on the bottom. There's a common factor of 7 for that part of our fraction. Then for the second fraction, 21, I can break down. It's 3 times 7. And then there's a common factor on my denominator of 3 that we can pull out. So now that I've factored everything completely, let's look for those common factors. So I have a common factor of 3x minus 4, and a common factor of 3, and a common factor of 7, and a common factor of x minus 2. So here we may think, oh, everything's gone, all my factors are gone, I'm left with 0, but that's not true. All the things that we've canceled out have reduced down to 1s. So I essentially have still 1 over 1 as a fraction, or an overall value of 1. So now let's talk about adding and subtracting rational expressions. So here there is going to be kind of two ways to approach it depending upon whether I have common denominators or uncommon denominators. So the first one we're going to look at is common denominators. So if the denominators of all the fractions that you're adding or subtracting match, then the addition is pretty simple. You just add across the numerator or subtract across the numerator while leaving that same common denominator for your fraction. So looking at my first example, everything's in terms of thirds, so my answer will also be over 3, and I would just add or subtract across the top. So 1 added by 4 is 5, minus 2 gives me 3, and then just like with all fractions, we want to reduce them if we can. 3 over 3 is reduced to a value of 1. For our second example, even though we see x's and y's, the rules work the same way. I do have a common denominator of 3y, and I would go ahead and add across the numerator. 8x added with 1x is 9x. And then again, I want to simplify. Here I can notice that there is a common factor of 3 here. 9 is 3 times 3. So I can cancel out that common factor of 3, leaving me with 3x over y.